I am B N Ramakrishna, e-content developer, digital learning, Department of Collegiate Education. I am going to explain the stellar characteristics for BSc 5th sem students, Astronomy and Astrophysics paper. In stellar characteristics, in this session, we are going to understand the stellar evolution, the evolutionary track of stars. The learning objectives are the concepts of stellar evolution and the evolutionary track of stars. Here, the students must be able to understand the stellar evolution and the evolutionary track of stars. The contents of these sessions are the stellar evolution and the evolutionary track of stars. See, first we'll learn about the stellar evolution. The life cycle of a one solar mass star such as the Sun is expected to follow the following stages: star formation, protostar stage, pre-main sequence stage, main sequence stage, red giant stage, and white dwarf stage. See, the birth of a star. A star is born when atom of light elements are squeezed under enough pressure for their nuclei to undergo fusion. As long as the inward force of gravity and the outward force generated by the fusion reaction are equal, the star remains stable. Clouds of gas are common in our galaxy and in other galaxies like ours. So here the luminosity versus surface temperature shown in the graph, how the surface temperature, the luminosity of a star depends on the surface temperature. A surface temperature is keep on increasing, the luminosity is decreasing. The detail of luminosity versus surface temperature is shown in the graph. Maturity. During the period of star remains in the main sequence, the release of nuclear energy at the center balances the inward gravitational force. In the process of hydrogen burning, helium is continuously formed as a result of the consumption of hydrogen in its core. This proceeds either by the proton-proton chain reactions or by the carbon-nitrogen cycle. As nuclear energy is released at the center, the temperature of the star rises. The star becomes more and more luminous. The star becomes more and more luminous. Aging stars. The helium formed by fusion collects at the center. Now there is no burning of hydrogen at the center. The core contracts, the outer layer expands outwards. As the size of the star increases, the amount of energy radiated per unit area of its surface decreases. As a result, the surface temperature of the star decreases to a value between 3000 Kelvin to 4000 Kelvin. The temperature drop changes the color from white to red. The star now leaves the main sequence and heads towards the giant stage. So next stage is the death of a star. See, when the temperature of helium core reaches 10 power 8 Kelvin, helium nuclei starts fusing into carbon through the triple alpha process. But a star of low mass relatively soon runs out of helium and the core collapses into a white dwarf, while the outer regions drift away into space. Larger stars have sufficient helium for the process to continue so that heavier elements up to iron are formed. When helium has all been consumed, there is a catastrophic collapse of the whole massive structure, resulting in a supernova explosion. Thereafter, the burnt out remains become neutron stars and black holes. So these are the points related to the death of a star. Now another stage is the evolutionary track of stars. See the another concept, evolutionary track of stars. So here, there is a graphical representation of a star's life as the path on the HR diagram. Moving through a track on the HR diagram means as the star ages, it traces out a path on the HR diagram. The brightness, temperature and size changes. So you can see here in the graph HR diagram, Hertzsprung-Russell diagram. So you can see here in this graph there is a variation, luminosity versus temperature, absolute magnitude versus temperature for different spectral classes. So you can see there are different stages of stars like red supergiants, red giants, white dwarfs, sun, blue giants, main sequence stars shown in the graph. The evolutionary track of stars. Here, for evolutionary track of stars, see the evolutionary track of stars with different initial masses on the HR diagram. The track starts once the star has evolved to the main sequence and stop when fusion stops. That is for massive stars. And at the end of the red giant branch, that is for star 1 mass of sun and less. The main sequence is the location in the HR diagram for stars in the first phase of their evolution when they are fusing hydrogen in their cores. This causes high mass stars to be much more luminous. An O star is about 10,000 times more luminous than the sun, but it also shortens their lifetime. The references for these concepts shown here. So thank you.